Let's do this problem right here. Compute the 1000th power of matrix M. If I had asked you this 3 weeks ago when you were learning about matrix multiplication, you would have run away, right? How am I going to multiply this 1000 times? But fortunately now you know that there is an easy way of doing it by diagonalizing the matrix, and then it's very easy to diagonalize the diagonal matrix to the power n, to raise the diagonal matrix to the power n. And in order to do that, you would first calculate the eigenvectors and eigenvalues. I have already done this for you because this was the topic of previous videos, calculating eigenvectors and eigenvalues. But this would always be a first step. If I ask you to calculate a high power of a matrix in an exam, you would first have to calculate eigenvectors and eigenvalues, right? So once you have those, then it's very easy to raise the matrix to a certain power. So we apply the recipe that we learned. So matrix M is equal to a change of basis matrix times a diagonal matrix times a to the minus 1. And we know exactly what these matrices are like. So matrix A contains the two eigenvectors, so V1 and V2. Matrix D contains the two eigenvalues, lambda 1 and lambda 2. And matrix inverse of A is just the same matrix as A, but inverse. By the way, a common question that students ask me is the order of the eigenvalues important? How do you know which one is the first and which one is the second? So the order doesn't matter, actually. You can choose this one to be first and this one to be second, or the other way around, this one first and this one second. But you have to be consistent. So whatever eigenvector you put first, make sure you put the corresponding eigenvalue first, and also the eigenvector first when you calculate the inverse, okay? And then whatever vector you put second, you put the corresponding eigenvalue second, and the eigenvector here the second, okay? So the order doesn't matter. Okay, so let's do this. So the first eigenvector is 2, 1, and the second is 1, 2. The eigenvalues are 2 and 1/2, 0 and 0. And the inverse matrix is, let me just write it down. By now you know how to calculate inverses. This is 1/3 of 2 minus 1 minus 1, 2. Okay, so knowing that this is true, then you know that m to the power 1000 will be equal to a times d times a to the minus 1 to the power 1000. But as I just showed you in the previous video, that can be simplified because all the a's cancelled with the a minus 1s. Yeah, they cancel out. So you end up with a times d to the n times a to the minus 1. So this is equal to a times d to the power 1000 times a to the minus 1. Okay. And you can write this very easily. So a is 2, 1, 1, 2. D to the power 1000 is simply 2 to the power 1000, 0, 0, and 1/2 to the power 1000. And that's because it's a diagonal matrix and you can very easily calculate the powers. We could actually write this, instead of as 1/2 to the power 1000, we can write this as 2 to the power minus 1000, right? It's the same thing. Times the inverse matrix, which is 1/3, 2 minus 1 minus 1, 2. And now we just have to do these matrix multiplications in order to arrive to the final answer, okay? So let me do it. So the first let's multiply these two together. So this is equal to 2 to the power 1000, 0, 0, 2 to the minus 1000. And I'm going to use the trick, putting it up here. 2 minus 1, minus 1, 2. For now, I'm going to move the 1/3. Maybe we can move it to the front, yeah? Because it's a scalar, and the scalar can move around. So, what's the product of these matrices? Maybe I don't have space here. So this is 2 to the power 1000 times 2 plus 0 times minus 1. That's 2 to the power 1001. Next, 2 to the power 1000 times minus 1 plus 0 times 2. That's minus 2 to the power 1000. Next, 0 times 2 times 2 to the power minus 1000 minus 1, that's minus 2 to the power minus 1000. And finally, 0 times minus 1 plus 2 to the power minus 1000 times 2, that's 2 to the power minus 999, right? So be careful, don't get confused with the powers here. Do the multiplications carefully. So therefore, this is equal to, I moved the 1/3 before, I have still not multiplied this first matrix, but I have multiplied the rest. So I have done this times this. So the result is 2 to the 1001 times minus 2 to the 1000 minus 2 to the minus 1000 and 2 to the minus 999. And now we would do the same with these two matrices. We multiply this times this, okay? So just do your trick and be careful with the powers of 2. I'm not going to use the time now doing it. You can test that if you want. But the final result looks like this. It's 1/3 times this matrix. 2 to the power 1002 minus 2 to the power minus 1000. That's the first element. Then minus 2 to the power 1001 plus 2 to the power minus 999. Then 2 to the power 1001 minus 2 to the power minus 999 and minus 2 to the power 1000 plus 2 to the power minus 999. So that's what you get when you multiply these two matrices. You get this one. Okay? And that's it. So you have been able to calculate m to the power 1000. In fact, I could have asked you to calculate m to the power n and leave everything as n instead of substituting 1000. Okay? So that is also possible. In fact, if we had done power n instead of power 1000, it would have been very easy. M to the power n would have been this matrix here. That would have been m to the power n for any value of n. Okay? Interestingly, you can actually use this formula now to do some special things, such as, for example, calculate the inverse of m by substituting n equals -1, and you actually get the inverse of m. You can also do interesting things. For example, what if n is not an integer? What if you want to do m to the power 1/2? So this would be like the square root of a matrix m. You can actually also do that, and if you find this matrix m to the power 1/2, when you multiply that matrix by itself, you get back m, as you would expect. Square root of m times square root of m equals m. So very interesting results suddenly open up. And in fact, in the next video, I will discuss some possibilities of now we can do functions with matrices. We can not only multiply, but we can do other functions, such as the square root. So see you in the next video.